Assalamualaikum warahmatullahi wabarakatuh. My name is Abid Muizzuddin bin Muhammadiyah, and today I'll be presenting my continuous assessment for basic algebra subject entitled Linear Programming Problem in Gym Membership Optimizations. And this study explores how a local gym can use mathematical modeling to maximize its monthly profit while managing operational constraints. So let's start now. So, let's begin with a bit of context. So, in today's modern society, the fitness industry is booming and more people are becoming health conscious, and gyms are evolving into lifestyle hubs and not just places to exercise, but spaces that promote physical health, mental well-being, and social connection. So, with this rise in demand, gyms face a critical question: how can they optimize their membership offerings to maximize profit while staying within budget and space limitation? So, the problem about gym membership optimizations. A local gym is planning to offer two types of gym memberships. The first type is standard gym memberships, and the second one is premium gym memberships. So the gym aims to determine which one is the most profitable combination of standard and premium memberships while considering its operational constraints, like trainer budget, facility space, and minimum revenue targets. So let's move on to the next slide. So this is the K-Fit membership price list. The standard one, as you can see here, the standard one costs 100 ringgit per membership, and while the premium one costs 200 ringgit per membership. And this gym offers two main membership categories, which is standard and premium. And despite the price difference, both memberships yield the same net profit of 45 ringgit per member after accounting for operational and training costs. And this leads us to our objective, which is to maximize total monthly profit. Alright, so how many members should the gym register in each category to achieve the highest possible monthly profit? Um, alright, so the first step is we need to know the decision variable. So yeah, to model this problem, we define two decision variables. Let the X be the number of standard membership sold per month, and let Y be the number of premium membership sold per month. So our goal is to find the optimal values of X and Y. So now let's look at the constraints that shape our feasible region. The first constraint is trainer budget constraints. So this constraint ensures that the total spending on trainers does not exceed 20,000 ringgit. So each standard member requires 50 ringgit of trainer resources, while each premium member requires 150 ringgit. So the inequalities that we get here is 50x plus 150y less than or equal to 20,000 ringgit. And after we simplify these inequalities, we get x plus 3y less than or equal to 400. And the second constraint is facility space constraint. Standard members use 1.2 units of space each, while premium members use 2 units, and the total space used by all members must not exceed 700 units. This means that the total space that available is 700 units. So 1.2x plus 2y is less than or equal to 700. Alright. So the second constraint is minimum premium revenue constraint. So this condition ensures that the gym earns at least 50,000 ringgit from premium membership each month. So for the first month, we need to get 50,000 ringgit for premium revenue for premium memberships. So the inequalities that we got here is 200y must be more than or equal to 50,000 ringgit. And after we simplify these inequalities, we get y is more than or equal to 75. And the next one is our minimum standard revenue constraint. So this condition is the same like the constraint that before, which is this condition ensures that at least 10,000 ringgit is generated from standard membership. The last one is for premium membership, and um, now it is for the standard memberships. So the inequalities that we got here is 100x need to more than or equal to 10,000. So after we simplified it, we get x is more than or equal to 100. Alright, so let's look at our last constraint. It is non-negativity constraint. So this ensures that the number of memberships cannot be negative. So x is more than or equal to 0, and y is more than or equal to 0. Right? It is because we can't sell negative memberships. And let's determine the objective function. So our objective functions represents total monthly profit. So as we can see here, each standard memberships earn 100 ringgit in revenue and cost around 55 ringgit in trainer and operational expenses, while each premium membership earns 200 ringgit and costs approximately 155 ringgit. So after deducting these expenses, both categories produce a net profit of 45 ringgit per member. So as you can see here, therefore, net profit is equal to selling price minus operating cost. So the next step is we look at the trainer budget and revenue per membership. As you can see here, the standard one, the revenue is equal to 100 ringgit, while the trainer cost is 50 ringgit, and the premium one is 200 ringgit for the revenue and 150 ringgit for the trainer cost. So after we calculating the net profit per category, the standard one 100 minus 55 equal to 45, and the premium one is 200 minus 155 equal to 45. So this leads us to our objective function, resulting the total monthly profit P is P equal to 45x plus 45y. Alright, so this function will be evaluated at each corner point of the feasible region to find the maximum profit. Okay, so let's look at our steps of solution. The first step, we need to plot the constraint, and the second step, we need to evaluate the objective function, and the last step, we need to identify the optimal solution. So what are our target here? So it is to solve the linear programming problem. Alright, so let's look at the first step. The first step is plot the constraints. So each constraint is plotted as a straight line on a graph, with X representing standard memberships and Y representing premium membership. So the feasible region is the area where all the constraints overlap, and this region contains all possible combinations of X and Y that satisfy the game's operational limit. Okay, the next step is we need to evaluate the objective function. The profit function is given by is P equal to 45x plus 45x plus 45y, and each feasible corner point is tested in this equation to find the total monthly profit. Okay, so as you can see here, let's look at one by one. The corner points, the coordinate of x and y. The first coordinate is 100x and 75.5, while the second one is 175.5 and 175x and 75y. Alright, let's look at the number one. So our calculation here is 45. We insert the number here into our inequalities, into our equation, and then we get the profit 7,000 ringgit and 875 ringgit. And after we enter the second, we insert the second coordinate into our profit function, we get 1100 11,250 ringgit. So clearly, as you can see here, the second point yields a higher profit. So Based on our calculation, the optimal solution is at coordinate xy, which is 175 and 75, giving a maximum monthly profit of 11,250 ringgit. So this is the equation we get here. P equal to 45. Insert the number that we got here, 175 plus 45, multiplied by 75, and then we get our monthly profit, which is 11,250 ringgit. Alright, so this is our graphical illustration that we get after we insert all the constraints that we got, after we plot the graph, after um, we knew the optimal solution. As you can see here, the S1 label 1 is the optimal point, which is at 175 and 75, lies within the feasible region while maximizing profit. Right, and let's interpret the result. The first one is the trainer budget is fully utilized. The optimal solution is 175 standard and 75 premium memberships, giving a maximum profit of 11,250. And this shows efficient resource allocation and balanced decision making. Alright, so from our graph analysis, we can know that our trainer budget is fully utilized, which limits further membership increase, while our facility space is not fully used. So this is indicating a potential for future growth. And the last one is both revenue constraints are satisfied, ensuring financial abilities. Alright, so from this analysis, we can draw several strategic insights. The first one is we can increasing. The first one is increasing the trainer budget or hiring more staff can expand profit potential. Right? So increasing the trainer budget or hiring more staff could allow for more memberships and higher profits. And the second one is adjusting pricing or promoting premium upgrades can enhance revenue. And the most importantly, linear programming provides a data-driven framework for decision making, replacing guesswork with precision. So, objective business decisions instead of relying on intuition. All right. So, to conclude, our project today is the gym can achieve a monthly profit of 11,250 ringgit by selling 175 standard and 75 premium memberships, and all constraints are met, with the trainer budget being the main limiting factor. And another one is there's room for future expansions, which is especially in facility space, right? And the next one is this project highlights the power of linear programming in optimizing our business operation. So future improvement include increasing trainer budget, revising pricing, or introducing hybrid membership plans. So this is our reference. This is my reference that I use in my continuous assessment for basic algebra project. And then, all right. Thank you for your attention, and I hope this presentation has shown how mathematical modeling can be applied to real-world business decision. I would like to thank to Dr. Hazram for guiding me to complete this my continuous assessment for basic algebra subject. Alright, that's all, and thank you.